Hello, I'm Roger Bisbee from the Skill Builder channel, and today I'd like to talk to you about diamonds. Now don't get too excited because I'm talking about diamond cutting really, rather than diamond rings. In actual fact, the kind of diamonds they use in diamond cutting are not actually real diamonds. These diamonds are manufactured specifically because you can get a certain size and shape and consistency in them, and that makes them ideal for distributing around the segments or the rim of the cutting device. Now today I want to talk to you about diamond blades specifically. Now this is brought to you in association with CorePlus, who make diamond blades, but don't worry, it's not an advert for CorePlus as such. There's information here that will help you in your daily work and hopefully help you select the right diamond for the job and get a longer life out of it. So they do say that diamonds are forever, but actually that's not the case in diamond cutting. You need the diamond blades to wear out, and the reason you need the diamond blades to wear out is because you need to expose new diamonds to the cutting surface. In other words, if you just let that diamond blade run round until that top layer of diamonds were worn out, then it would be no good to you. So the idea is they embed the diamonds in, and it has to wear out according to the material you're cutting. Now this is very, very important. We've got to remember one important principle here. Hard for soft and soft for hard. Now it's worth bearing in mind that diamond blades don't really cut like a knife, they actually grind, and the diamond crystals or the grit is held in a metal matrix which is called the bond. Now this metal matrix locks each diamond in place. Trailing behind each exposed diamond is a bond tail, rather like a comet tail, which helps support the diamond. Now this matrix of diamond and metal bond is hot pressed under a massive amount of pressure and at a very high temperature to form a solid metal alloy, which you see as the blade segment. Now during the manufacturing process, individual diamond crystals within each segment are exposed to the outside edge of the bond. Now these exposed surface diamonds do the grinding work, and they score the material, grinding it into a fine powder. Exposed diamonds crack or they fracture as they cut, breaking down into even smaller pieces, and the hard dense materials cause the diamonds to fracture even faster, which sounds like a bad thing, but actually the embedded diamonds remain beneath the surface of the bond. And for a diamond to work properly, it's extremely important that the two most important elements of the blade are matching the material which is being cut. So the diamond type quality and the grit size must fracture and create new sharp edges at the right time during the cut. If the bond is too soft, you get too much exposure, and if the bond is too hard, you get too little exposure. So we want to find a happy medium. Now the metal matrix bond controls the exposure of the diamonds, and the bond's job is to expose the right amount of diamond at the right time to provide a smooth, fluid cut. You can buy blades which are specifically made for hard materials, and you can buy blades which are made for very soft materials. And CorePlus has both these type of blades in their range. Now the material being cut will wear away this metal matrix bond through abrasion. Highly abrasive materials will wear the bond faster, and this will expose new diamonds. The bond needs to be hard enough to prevent diamonds being exposed and wasted too quickly. The blade will cut the material, but the segments will wear down and you'll get fewer cuts and a shorter blade life. Now harder materials will wear the bond slower. New diamonds will take longer to be exposed, and the cutting will take longer because the segments are kind of glazing over. So it may be that you find you're not cutting at all. The solution is a softer bond that exposes the diamonds by the correct amount, delivering them to the cutting edge exactly when they're needed, resulting in a highly effective long life blade. Now it's important to understand that the diamond blade and the material must work together or interact for the blade to cut effectively. A general purpose blade is designed to perform well on both types of material, hard and abrasive. But because it must be versatile, there is always some compromise on the blade's life, as the bond isn't specifically formulated for that material. So the thing that you really need to take away from all this is that the diamond blade packaging will often state the height of the segments in millimeters, and because you're looking for value, you think the more millimeters the better. But that segment height by itself is not a true measure of the blade's value, because there's many other factors that affect the blade's performance. And I hope that this short video has helped you understand exactly what those factors are. The content of the segment is much more important than the size. Where have you heard that before? We try and find the right blade for the right material. And if you look at the CorePlus range, you'll see that on the back here, all the different materials that you can cut with the blade. And it also tells you that this is a general purpose blade. What does it actually mean? Well, it kind of suggests that what I've just told you is a load of nonsense. But what we're looking for here is a compromise. We're looking for something that will do the job for most common materials. And if you are cutting through a very hard material with that blade and it starts to glaze over, and you find that if you run your thumbnail across the edge of the diamond blade with the saw turned off, obviously, that you can't actually feel any tiny little bits of diamond there, that means the blade is glazed over. And what you then need to do is run that blade through some abrasive material, something like a soft concrete block or a brick or something like that, which will wear them down to a certain extent and expose new diamonds. And then you'll find that you can cut through with it perfectly well. Now, I've seen people chuck diamond blades away, perfectly good diamond blades with lots of segment life left on them, just because they've stopped cutting, and they chuck them in a skip and they say this is a load of rubbish. In actual fact, you can fish it out the skip, dress it down, and you've got a diamond blade which is good as new. Now, the next thing you need to know is whether you're going to be cutting wet or dry. Now, I would say that in every circumstance, if you can cut wet, you are better off. But there are limitations to cutting wet. But obviously, if you're in a customer's kitchen, you don't want to be flooding the place out. So you would cut dry in that situation. But if you can, if you're outside and you're using a petrol cut-off saw and you can get a water bottle onto it, or you can get a hose pipe onto it, you don't need a huge amount of water. Just a little bit of water dripping down there over the blade will keep the blade cool, and more importantly, it will suppress the dust so that it's not a health hazard to you and all the people around you, but also it'll mean that it removes the dust a lot more effectively. And if you remove the dust, the cut is a lot faster. So wherever you can, cut wet. But if you can't, you have to cut dry. There are some blades which are made to cut wet, and these would be the continuous rim blade like this for hard materials. They're always better to cut wet, because if you look at them, that continuous rim has no segments in it. There's nothing much there to clear the amount of dust and debris. There's tiny little nicks all the way around the side of this blade which are there actually to help clear that dust. So this is what they call a turbo blade, and it's used for things where you don't want to be chipping. This blade is a segmented blade, and you can see that you've got a gullet in between each row of segments there. That gullet is there. One thing to reduce the stress on the actual core, but the other thing is that it allows a little bit of expansion and contraction if the blade gets hot, but also it clears the dust. Its most important function is in clearing the dust. It's a bit more expensive than the CorePlus standard range, but it does give you more bang for buck. In other words, when you start measuring the number of cuts that you get out of it, you do actually get more. So it's not always a good idea to go too cheap. Another reason that it's not always a good idea to go too cheap is because these segments have to be joined to this core, and the way that they're joined is very, very important indeed. Now, you can just braze them on, and if you've had blades for some time like I have, you will have suffered a segment loss at some time. Now, hopefully that hasn't happened when the blade's been spinning round and it's flown out and injured somebody. That doesn't happen that often, but it does happen. But generally, it's when you put the saw down and you just knock the blade, maybe while it's warm or something like that, and the segment falls off, or maybe the blade is twisted slightly in the cut or something like that. We do find it time to time that the segments fall off. Now, with these particular ones, they're double laser welded. So that segment is not just brazed, it's put on there with a double laser weld, and that means it's a lot less likely to be damaged. This is tested by OSA, which is the highest level of testing that you can get, and it ensures quality. If you go for a cheap blade that you don't particularly know the brand of, it may well be that they're just brazed on and they're not particularly well made. And even the core on some of those blades is a little bit dubious. In other words, it can start to buckle as it heats up and so on, whereas this is a magnesium steel core, very, very tough indeed, and it won't distort, and it obviously gives the segments a lot better chance of remaining on the rim. And you can see that we've got little flutes in here that allow the dust to be removed very, very effectively. You can see there's a little V groove in there which also assists the speed of the cutting. And you do find that if you're using this continuous rim blade, that the cut will be slower, because this, as you can see, has got a more aggressive segment in it, and because of those gaps in between, it's removing the dust faster and it's cutting faster. So accept the fact that if you need to cut something like porcelain tiles and you don't want the chipping that you would get with something like this blade, then if you're using a continuous rim blade or turbo blade, then you're going to have a slower cut. So it's important that if you are cutting dry, that you allow that blade to cool down a bit. You will find that dust extraction can help that process, by the way, because you're sucking air through all the time, you're clearing the debris, and you do find that the blade cuts cooler if you can get dust extraction. So if you're cutting on that kind of blade, dust extraction is fairly unusual on a cut-off saw, but you will find in hole saws and things like that that you can get some good dust extraction kits. So the important things to remember when you are choosing a diamond blade: make sure that it's got all the safety certificates, make sure that it's been fully tested so that it's not a danger to you and the people around you. Then look at the materials that you're intended to cut. And I know this is difficult because if you're a general builder, from day to day you don't know what particular materials you're dealing with, but on the back here you can find the guide on these CorePlus ones. It's very, very easy to understand. It's all there for you to follow, so just make sure that you're getting a blade which is best suited to your material. Then work out whether you're going to cut dry or you're going to cut wet, and avoid that dust if you are cutting dry. And if you are cutting dry, also don't forget to allow the blade to cool down every so often. Don't just go using it as a machine, cutting hundreds and hundreds of cuts off a, you know, if you were doing a repetitive cut and you had to cut loads and loads of bricks all to the same size, then just take a break every so often, move a few bricks out the way, and that just gives the diamonds a little chance to cool down and recover. And you will find that you'll get a longer life out of your diamonds if you just follow these simple rules. So I'm Roger Bisbee, thanks very much for watching, and my grateful thanks to CorePlus for helping us bring this video to you.